In the following video, we're going to examine how to find both the maximum and the minimum values of a function involving linear programming. So let's first take a look at the example. Graph the following, find the maximum values of the function f of the coordinate xy equals 9x minus 6y. And we're told 3x plus 2y is greater than or equal to negative 12, y is less than or equal to 3x plus 12, and y is greater than or equal to 3x minus 6. So I see in these bottom two inequalities, they're already in slope-intercept form for me. But in the 3x plus 2y, I need to convert this one to slope-intercept form. And so I will use blue to represent that inequality. So that way I can see each graph relating to their inequalities. So I have 3x plus 2y is greater than or equal to negative 12. You would get the y by itself by subtracting 3x from both sides, giving me 2y is greater than or equal to negative 3x minus 12. And then to get the y, so it has a coefficient of 1, I would divide all my terms by 2. And so you have y is greater than or equal to negative 3/2 x minus 6. And so there is my slope-intercept form. So I'm going to take my inequality and I'm going to graph it. I have a y-intercept of negative 6, and I have a slope of negative 3/2. So down 3, right 2, down 3, right 2. I go up 3, left 2. And remember, the reason why you go across the entire grid is because you want to find your coordinates, the vertices where your inequalities intersect. And so you need to plot all the points with the slope so that way we can see where our vertices are. And it is greater than or equal to, so that's going to be a solid line through these points. And greater than, your y greater than values are above the line. And so I would shade above the line. Remember, I use little lines for the shaded region in the beginning because it allows me to erase, it allows me to look for a crisscrossing pattern on where my solution region is. And so for the next one, y is less than or equal to 3x plus 12, it's already in slope-intercept form. So I'm just going to go ahead and graph. You have a y-intercept of positive 12, a slope of 3. I can't go up 3, right 1, so I'm going to go down 3, left 1, down 3, left 1, and so on and so on across the entire grid. Now, if I look right here, I see when I went down 3, left 1, it looks like it intersects our other inequality. And so that represents one of our vertices we're actually looking for. So I'm going to continue to go down 3, left 1 so I can graph my inequality properly. And you're told y is less than or equal to. So in position to this line, where are your lesser y values? They're under it, they're below it. So then we are in a shade under that line. And when I do this, I see I have my crisscrossing pattern occurring in that area to the right over here. So I'm going to erase the other lines. And that way I can see somewhere in this vicinity is my feasible region. And so I now need to graph that last inequality. Y is greater than or equal to 3x minus 6. So you have a y-intercept of negative 6 and a slope 3. So as soon as I plot my y-intercept, I see it intersects one of the inequalities. So that is one of my vertices. So up 3, right 1, and so on. Follow that pattern across the entire grid. Up 3, right 1. And then come back to your y-intercept of negative 6 and go the opposite direction, down 3, left 1. And connect, it is greater than or equal to, so it's a solid line. And your greater than values and position to this line we graphed are above it. So then we're going to shade above it. And so if I shade in that area above it, I want to look on where do all the colors overlap. And it looks like they all overlap in this middle region right here. So let me erase the other one so we can see it clear. So I can erase this area. I can erase everything under here because I don't see all three colors. And then erase this section to the right. And so what it looks like this is our overlapping region. That is our feasible region. So let us highlight it so we can see it clear. Here is where our solution region for the inequalities lies. And so I need to find what are my vertices for this. Well, if I take a look, this was my first coordinate where they intersected. And that is the coordinate -4, 0. And then I saw down here was the other coordinate they intersected, and that is the coordinate 0, now -6. Now here's the interesting part. We're told to find the maximum and the minimum values. If we look, these lines extend on forever. And so there are no vertices up here. This shaded region will continue to go up and up and up and up forever. So we only have 2 vertices for this example. And we're asking for the max and the min, which tells you one of these is the max and one of these is the min. And we just need to plug them in and find out. So the function we use, f of x, y, the function add the coordinate of your x, y, let's do -4, 0 first, is 9 times your x, which is -4, minus 6 times your y, which is 0. So you get -36 minus 0, which is -36. And then your function at the coordinate, your xy coordinate, 0, -6, is 9x, so 9 times 0, minus 6y, which is -6. So you get 0, -6, and -6 is a positive 36. And so 0 plus 36 is 36. And so we're asked to find the maximum and the minimum values of this. And so if I take a look, there's only 2 options. And so my maximum value is 36. So the way we state this is our max value. We have max value of 36 and it occurred at the coordinate 0 and -6. And then we have our minimum value. And so that would be -36 here. And so we have a minimum value of -36, and that occurred at the coordinate -4, 0. And so there you have it. We have our maximum, our minimum values for the function of the coordinate xy given to us in the problem. So hopefully this was a little bit easier for you to understand because it is just the idea of system of inequalities and identify your vertices. It's just when you find your vertices, you're given a function to plug them into. And then you just perform out of order of operations and determine which value is your maximum or minimum for it.